Hello all, today in this video I am going to make a demo video for spam detection, email spam detection. Already with the same data set we have worked with some other algorithm. In this work demo we are going to work with KNN. Initially we are going to import the libraries we are needed, and then we are just calling our data set. The data set I downloaded from Kaggle. So if you normally give us email spam detection data means Kaggle means you can just download this data. So this data is having nearly 3002 columns. Within the first 3000 and one column we are going to use as the x variable, and the last variable we are going to use as the y variable, that is the prediction one. Here you can notice that we are going to get the info of the data. Within this info you can notice that the integer value is 3001 and object is 1. So this one value is only the object type, others are integer type only, so only it is coming like that while getting the info. And we are getting the null values also, whether checking whether our data set is having any null values. It is not having any null values, so we are moving to the detection of x variable and y variable. Already I said that how we are framing the x variable and y variable. Within the x variable we are just choosing the first 3000 entries, and in the y variable the last is chosen as the y variable. And by using this x variable and y variable we are determining x train, x test, y train and y test variables with the help of train test split function, and the test size as 0.25. So if you want some other size means you can just change it. Here I am just if by this we are getting 25% for testing and the remaining 75% for training. Already with the random forest we have worked, and we have got an training accuracy of 100 and testing accuracy of 9.9737. And we have also displayed an graph ROC curve with FPR, that is false positive rate in the y-axis, and truth positive rate in the uh, uh, false positive rate in the x-axis and truth positive rate in the y-axis. Then previously in the previous demo we have worked with the SVM and got an accuracy, training accuracy of 0.8092 and testing accuracy of 0.7710, and we have also declared its ROC curve. Then we worked with the naive Bayes and we got an training accuracy of 0.9646 and testing accuracy of 0.9590. And we have also plotted the ROC curve for this. Then we have in this code we are going to work with KNN, that is K neighbors classifier. Here we are having declared that we are having daily 7 neighbors. The only difference is that we have to only change this library. Everything's are same only. Here also we are going to determine training accuracy, then training ROC, AOC score, likewise testing accuracy and testing AOC, ROC, AUC score. Everything will be same only the library and this declaration will only vary. So now we are just going to run our code. So while it's running, we will also see the other details. So finally, we have also made an comparison. For the comparison, we have made a models variable, and we are going to display every models variable over here. For that, we have to just call its name over here, and the function which we are using here, we are using the k neighbors. we can just give us KNN. And then we have made a loop, and within the loop we are calling the fit function, that is the train function, predict function, that is the testing function, and we are going to declare the variables like accuracy, mean square error, and R2 square, and we are going to make a display the training accuracy and testing accuracy of every model within this single cell. And then we are also going to make an table. So within this table we have made some highlight points, like the model with the lowest accuracy will be showing with the red color, and with the highest accuracy will be showing like green color. So to in order to make an comparison, so we shall wait until our model has run. As of now, random forest is completed its execution. SVM is running. Since it is taking more time, this out details from SVM will make in the next video. Thank you.